Hi, this is Rob Yates, and this is the video for classwork number 4 for Algebra 1. Classwork number 4, as I hope you are aware, is page 25 and 26, numbers 52 through 55. Alright, the first thing we need to do is to write down the table that's given to us in 52. Okay, you can see I put a star over the output and input for 0. And the reason for that is most functions are something like y equals 2x plus something, or y equals x squared plus x plus something. When we plug in a 0 for the x, these all go away, and we're left with what we know they're adding or subtracting at the end. From this, we can tell that they're subtracting 1. Minus 1 seems to be the very end of whatever kind of function's going on here. If we look at our x's, they are normal. They increase by 1. Plus 1, etc. If we look down here to see if there is a constant rate of change in our outputs or our y, we can see that this is 5. Excuse me, that's a minus 5. This is a minus 3. That's a minus 1. That's a plus 1. That's a plus 3. So really, what's going on there is not a constant rate of change. That it's not some kind of linear rate of change. It is something else entirely. So let's try and figure out what it is. The way we can do that is we take our 1 that's been subtracted, that we know has been taken away from our output, and we add it back in, and we try to figure what's been done to the input to make it so. In other words, I know that this 8 is really 9 minus 1. If I added 1 back in, it would be a 9. This 3 would really be a 4 before the 1 was subtracted. This 0 would be a 1. This negative 1 would be a 0. A 1, a 4, another 9. So my question is, what do I do to 3 to make it equal 9? Three plus 6 is 9, but 2 plus 6 does not equal 4. 3 times 3 is 9. So that works. 2 times 3 is not 4, though. But 2 times what is 4? That's right. If I look over at this end, negative 3 times 3 is negative 9, so that doesn't work. But negative 3 times negative 3, what is that? So I think what we can say safely is that the inputs are doubled, or in this case what we call squared in math. X squared minus 1. That's our function. Negative 3 times negative 3 is 9, minus 1 is 8. Negative 2 times negative 2 is 4, minus 1 is 3. Negative 1 times negative 1 is 1, minus 1 is 0. Of course, 0 times 0 is 0, minus 1 is going to be negative 1, etc. It fits. So there is our equation. '53 tells us to take our function, which is the f of x, equals x squared minus 1, and have an input of 4. So if I plug in a 4, the f of x equals 4 squared minus 1. What is 4 times 4? I think you know that. Subtract 1 from that number, that's your answer. For B, because that was A, it says, now find out what happens if we plug in negative 1. What is negative 1 times negative 1? If you're not sure, plug it into your calculator. And then subtract 1. That's your answer. Also on B, they want us to tell them what would happen if I input 10. What is 10 times 10? And now you subtract 1 from that number, what do you get? There's your answer for the second part of B. C is a little bit different. It says if the output's 24, what is my input? So it says if my f of x is 24, what is my input? 24 equals x squared minus 1. We would solve this by getting our numbers on one side and our letters on another. So I would add 1 to get rid of negative 1, and I would get 25 equals x squared. What is the opposite of x squared? If we want to get x from that x squared, how do we do that? I'll give you a little hint. That's the symbol for it, right here. If you square root both of those sides, you'll come up with the answer. What is the square root of 25? 54 is another table. Instead of y this time, we have f of x. And it says find the relationship between the inputs and the outputs, between x and f of x. And it gives us a partially filled in table. Extra points if you can tell me why I starred these 3 columns in the table. Why do you think I did that? If you said to yourself, because those are the 3 that have both an x input and an f of x output, the answer is yes. They're going to help us find our pattern. For instance, what am I going to do to 25 to make it equal 5? Or how about over here? What do I have to do to 49 to make it equal 7? Do you know? If you said this right here, square root, you're correct. The square root of 25 equals 5, and the square root of 49 equals 7. So, you have to run down along your table and ask yourself, what is the square root of 9? If you said 3, you're right. What's the square root of 10? I'm not going to tell you. Fill it in. What's the square root of 4? I'm not going to tell you. Fill it in. Oh, wait, over here, 4 is the square root of what? Another way to say that is, what is 4 times 4? Square root of 0. How about 20? 20 is not a nice even number like 25 or 49. You're going to have to plug that one into your calculator. Remember, on your calculator, it is second button, x squared button, plug in your number, in this case, 2, then 0, then close your parentheses, then hit enter, and you will get your answer. Let's move on to a couple of 55, and then I'm going to leave you to your own devices. In 55, it gives us a series of 9 functions, machines A through I, and it says find the corresponding outputs or inputs. That means sometimes they're going to put in a number and you're going to tell me what comes out, or sometimes they're going to say this is the number of what that comes out, what goes in. The first one is x equals negative 3, and the function is negative 2x plus 4. When I'm plugging in an input, I take my negative 3 and I put it right here. So my equation is this, or my function is negative 2 times negative 3 plus 4. Remember your order of operations. I have to do my multiplication first. What is negative 2 times negative 3? Remember, what's a negative times a negative? If you said positive, you are correct. So negative 2 times negative 3 would be 6. You add 4, and there's your answer for A. The rest of these I think you will be able to handle. I want to remind you about absolute value. Remember, absolute value is always positive. So if it asks you what the absolute value of negative 6 is, the answer would be 6. Also want to remind you that if you get a problem like D, which asks you to plug in a negative 2, x equals negative 2, to a square root function, can I get the square root of a negative number? The answer is no, I cannot. A negative number by its very definition is the product of a positive and a negative number. It can't be made by the same two numbers, either two negatives or two positives. So, there's no output for any problem where they ask you first to come up with the square root of a negative number. All right, good luck. Remember, there are tutors in the library before and after school. Your algebra teachers are available to you after school and before school. Please contact them. Don't get behind. It's too much work to catch up when you are. Thanks again.